Hello, my name is Robert Neely. I'm a construction science student at Tarleton State University. My engineering economy class, we did a cost estimate for 500,000 shears. I'm going to show y'all my calculations and a little bit of background about this product. So, brief outline of how this presentation is going to go. I'm going to have an introduction, talk to y'all a little bit about why estimating is important. Then I'm going to have some background information on shears and why I chose to do this product. And I'm going to get into my methodology, which is how I came about getting my numbers for my calculations and what kind of estimating style I went for. And after that, I have my results, so what they sound like, my calculations, my part totals, my part costs, all that kind of good stuff. And then I have my reconciliation, which is where I reconcile the difference between my estimate and the actual cost. So let's get into it. Why we estimate? Estimating is arguably one of the most important parts of a business. It's where a business decides whether or not they want to even go after a job, how they want to price that job, how they want to bid on it. In this case, it's how a business decides what they need to sell this product at to break even on $500,000, which is so that way they don't lose money. So, why I chose shears? It's an interesting topic, and I just wanted to learn a little bit more about it. The first shears they were invented 3,000 to 4,000 years ago in Egypt. That's what they looked like. Definitely evolved a long way since then. And so, next, it's one of the first tools we give kids in kindergarten. We give them glue, scissors, crayons, pack of pencils. Have fun. And if we're giving kindergartners this time, we also use them in our yard. So we use them for all sorts of things across America and across the world. So I just thought it was really interesting. My methodology, I did a semi-detailed estimate, negative 15%, where the range for this estimate is within negative 15% to 20% of the actual cost. It's for budgeting purposes. I use the segmenting model of estimation, which is where you break out each individual part cost, each individual labor cost, and then you add it all up to get one unit, and then I multiplied that by our 500,000 units. Or to get these numbers, I watched a lot of YouTube videos that helped me figure out the part cost, the labor totals that were going to go into it, so that really helped a lot. There's no tax for shipping, and we're shipping an $85 burden rate per hour for the shop. So, the material cost estimate. First order of business, we have steel. We use 6 ounces, and it's 65 cents an ounce. So that comes out to $3.90. Then we have oil to make sure that the scissors are properly lubricated for the life of the scissors. That comes in at 23 cents, and we use half an ounce. So I just rounded up to 12 cents per unit. Then we have a bolt, which is 15 cents a unit. Then we have a nut, which is 18 cents. Then we have the plastic, which we only used 1 ounce. And that's 27 cents an ounce. That's for the finger grips on the scissors. Then we use the adhesive. We use 2 ounces of that. That comes in at 13 cents. Then we have the dies that go into the plastic for the finger grips. And that's 14 cents an ounce, and we only used 1 ounce. So that brings our part total out to $5.02. Now we're gonna go for the labor cost breakdown. The first thing on the first order of business, once again, is making the actual blades. That's with the steel, and so that whole process of blade crafting took half an hour. What goes into that? Pressing the blade, we melt the steel down, get it to how we want to go, and pour it in the mold. That took quarter of an hour. Then we have shaping the blade, which it's making the blade in the shape that you need it to be in order to be sellable. And that took 5/100 of an hour. Then we have heat treatment and cooling. That took 1/10 of an hour. And that's just getting the blade cooled down enough so that way we can grind it, which is, as we all know, putting the sharpness and putting the edge on the scissors. And that took 5/100 of an hour. And then we have polishing, which is getting the blade nice and shiny and where people actually want to buy it. And that also took 5/100 of an hour. Now we have the plastic handles. These are for the finger grips, once again. So the first thing you have to do, for the whole plastic handles, they took 2/10 of an hour. First thing you want to do is you want to mold the plastic handles. And that took 1/10 of an hour. Then you want to thumb punch the blades for the finger holes, and that took 5/100 of an hour. And then you want to put the adhesive inside of the molded plastic, so that way you can assemble it properly, and that also took 5/100 of an hour. Then we have assembly itself. That took 1/10 of an hour, and then we have quality control, quality assurance, that took 1,500 of an hour. All in all, we ended up getting 9,500 of an hour, and so when we break that down, it's $5.02 for all the parts. Then we have 9,500 of an hour, like I said before, for our burden hours, and that at a burden rate of $85. it comes out to $80.75, which then we add that with our part cost. That comes out to $85.77. We multiply that by 500,000 units and we get 68,385,000. Now, when we're talking about reconciliation and what I'd like to do different next time, the first thing is I'd like to be a little bit more educated on my estimate. This is my first estimate. I didn't really know what I was doing. All things take practice with time. And so I got half an hour difference between my estimate and the actual cost. And so half an hour, 30 minutes, that doesn't seem like much. But it turned out to cost me $43.95, which once again, not that bad until you multiply it by 500,000 units, which that turns into costing me $21,972,500, which that turns out to be a lot of money. And then we have my part cost, which this kind of saved me, but not really because it's ending up what screwed me in the first place. And so I charged $5.02 a unit for the parts, and the actual cost was $15.74 a unit. And so what happened, once again, it saved me $10.72, which comes out to $5.3 million, which that sounds great, but we also have to remember I spent almost $22 million more on my labor costs. So $85.77 versus $52.57 over the course of 500,000 units. That turns out to be $97,500, which whenever we're talking about how I wanted to do my estimate as a semi-detailed estimate, my estimate was negative 65% off. That's a lot. That doesn't even meet the criteria for a rough estimate, which is negative 30% to 60%. And so next time whenever I do this estimate, I'd like to be a little bit more informed on how I actually am getting my numbers, and then the parts I buy and the labor that I do. I'd like to check that out all the way through the end and make sure that it's not going to come back to haunt me like it did in this project. So, thank you.